Hey everybody, welcome back to the channel. This video, I'm gonna do kind of a how-to video on how to charge the AC and what to look for with your AC pressures and how to add refrigerant to any R-134 system in vehicles roughly from 1994 up to 2016 and a few years past that. So again, this is just gonna be basically what to look for, pressures, how to add refrigerant, how to check refrigerant pressures, and I'm gonna deal with one leak that happened to me when I was adding some refrigerant to my Old Faithful here that after 24 years, she got a little bit low. So I'm gonna show you guys some refrigerant 101, some AC 101, using my truck here as kind of a blackboard, if you will. And I will say, for me, AC systems are simple. It's one thing I actually enjoy doing is fixing any type of AC problems with any fairly modern vehicle. I mean, when I say modern, I mean, 90s and up. That's not modern to some people, but it's modern to me. What I will say is, for me, AC comes easy. I actually like doing AC repairs. It's one thing that I do actually like to do when it comes in the automotive world. And if you guys aren't comfortable with this, then I suggest you do take it to a professional. I'd be more than happy to look at it, unless it's a 2002 Thunderbird or a 2017 Buick Lucerne, in which case you can take that shit somewhere else, because I am not going to touch it. Anything else, happy to look at. So I'm going to show you guys what I found out with this and show you some of the basics, okay? Okay, so let's start with how to add R-134A refrigerant to your vehicle. Okay, so you can do this with a set of gauges like I have here. If you don't have access to gauges, then a lot of people go into part stores and they buy the quick charge kits, which basically just have a large can of 134A and a low side fitting. And that will work for adding Freon as long as you know how to read the pressures. I highly recommend, though, doing it with a high side as well, because the high side, knowing what the high side pressure is just important as a low side, and it's quite possible you can overcharge the system, and that leads it to its own set of problems. But for right now, just going to start with low side pressures. So basically, you just plug this on, clip it on, and then you want to twist this knob all the way down. That opens up the valve. Right now here I'm showing, just under 70 PSI static pressure, which that tells you you have some refrigerant in the system. Now, if that was 0, then that makes it pretty simple. We've got to reiterate, if it's a 0, the correct way to do this would be to vacuum the system down, eliminate any chance of moisture contamination, and then charge it. But this is kind of the DIY system of showing you guys how to do it as simple as possible. So I won't get into evacuating and vacuuming down a system. This is just if you were to do it yourself at home. So plugged in the low side, turned it on, and let's say you have 0 pressure. Most vehicles, unless it's been removed, should have a sticker similar to this that shows you what system you have and exactly how much refrigerant you have to add. This is a pickup, not an SUV, so you go down at the bottom, pickup, with front AC only, 1.8 pounds. And when you go to a parts store, most of them have these type of cans, but the ones that you use to self-charge are a little bit bigger, but they're marked on the can how much is in there. So if it's in ounces, great. If it's in pounds, you got to convert that to ounces just so you match up how much you need and add that specific amount to your system. For my particular setup right here, these are 12-ounce cans, so I'm going to use 2 full cans plus about 1/3 of this can. And without scales or any other specific means, you just kind of have to go by feel of weight of the can in your hand of what is essentially 2/3 left of this can left, and you've used 1/3 of it. I know it's not very scientific, but again, this is 101 type stuff. This isn't a full-on AC course. So you're gonna crank that valve down all the way. You're gonna start the vehicle, turn the AC on max, and then sometimes you just have another valve and you open those up. On these gauges, it's pretty simple. You just crack this valve up here, open up the flow, and add your refrigerant till you get it all in, and you should be good to go unless there's other problems with the AC system. Now, if you're reading on the high side and you want to do this correctly, then let's say you have some refrigerant in here. I mean, like, let's say you're down at, say, 30 or 40 pounds. So you don't know exactly how much is in here. You do know it takes 28 ounces completely empty, but if you don't know if it has 4 ounces in it, 16 ounces. So that's where this high and low side reading comes in to be very important. So again, you're gonna make sure these valves are turned all the way down so both valves are open, but you're gonna wanna make sure up here on your gauges both valves are closed, because it's very important that you do not ever open the high side, and I'll get into that in a minute. You're only gonna want to deal with the low side. This high side will read with that valve closed, so you don't need to open this valve in order for the pressure to read. It will read automatically, assuming your valves are closed over here and they're both open to allow refrigerant into these lines. So you're gonna open the low valve and you're gonna start adding Freon. And you're gonna do it until your pressures reach a certain amount. And this is getting into kind of, in a way, kind of like voodoo, because the pressures aren't fixed. The pressures are determined a lot by the system, the design capabilities of it, and also ambient temperature. So if you're checking pressures when it's 60 degrees outside, they're gonna be substantially lower than if you're checking the pressures in the desert at 110 degrees, which would be substantially higher. As a general rule though, you would add Freon with this running on the low side. Your pressures would normally be optimally about 40 PSI while it's running. Now, some vehicles are substantially lower. Dodge pickup trucks, for example, run a lot lower. When they're fully charged, they can run down at 20 to 30 PSI, even in high heat. The high side is where it's really critical though, where you do not want to go over a certain amount for a healthy system. And normally when they're fully charged, the high side pressure will normally read anywhere between 200 and 225 at around 90, 95 degrees ambient temperature. It can read lower, and that's where the kind of, experience comes into play. Because on this particular truck, when I charged it, it was about 85 degrees, and the low pressure was exactly where I wanted, but the high pressure was only about 150 PSI. And this is my truck, so I know the system is good, and it actually works awesome, just like it always has. So a lot has to do with how much air your fan is pulling through your condenser and the ambient temperature for your high side reading. And I know I'm rambling on this a lot, but it is kind of important. But I would say, as a general rule, without getting into a whole lot of detail, the system is fully charged if, assuming, again, everything, all the components on the system are good and the system is healthy. An optimal pressure reading in roughly 90, 95 degree weather would be 40 PSI on the low side and roughly 200, 215 on the high side. I don't like to see pressures over 225. Usually that means you're starting to get overcharged or you start having issues with the system. If you know for a fact that you're not overcharged and your high side pressure is over 250, then you have one of a couple problems. Either one, your fan is not working properly, you're not drawing enough air through your radiator and condenser, or two, you've got a restriction in the system, bad compressor, something's going on that's causing high pressures, and you need a lot more than just charging your AC. You most likely need AC component replacement. And that is where this valve comes into play. Because there's been times where I've hooked up to check someone's AC on the high side, and I've got a can on here, and I go ahead and close that valve to check my pressure, and this gauge jumps to 500 psi. Now, I've never actually had it happen or have I done it, but I've heard that that's a good way to have this blow up in the face and have shrapnel go everywhere. So that's why you don't ever want to open the high side valve when you're charging from these type of cans, is because these can rupture at those types of pressures. So just a safety thing, keep this valve closed, especially if you don't know what that pressure is going to end up being. But needless to say, if you have a 500 psi high side with this type of system, you got major problems. Or somebody has severely overcharged your system. Okay, so let's say you don't have gauges. You just have the quick attach can tap thing that the parts store sells. And you don't want to mess with that. And you just want to drain the system out and add Freon. Well, if you don't have a proper evacuation machine and you just want to empty your system out and then refill it, well, that's between you and Jesus, but the government doesn't like that too much, and it's a pretty hefty fine, so I'd recommend not doing that. And in reality, AC systems are pretty simple. There's just not a lot of components, and I don't know why a lot of people are afraid to work on them, but besides the in-dash components, the electrical parts that control the stuff out here, which that stuff usually doesn't go bad, it's something out here that usually is failed, and either it's because of a leak or a compressor failure. And really, all you have on these systems, you have an AC compressor that's driven off the motor, usually belt drive, but sometimes it is an electric compressor mounted to the motor. A couple lines to a condenser up front here, another line comes back here. This vehicle has an orifice tube in the line right here, and then goes to the evaporator that's inside the dash, inside the vehicle. And then right here you have a receiver dryer. If you have rear air, then you have a few more components in the back, but most systems are like this or similar to this. The only difference is some vehicles, instead of orifice tube right here, you have an expansion valve that's usually right on the firewall where the lines go in. And normally there's about really only two things that fail on these type of systems. One is you have a leak of refrigerant somewhere, and that's normally a hose or an O-ring wherever there's a union, like here or here. You can develop leaks anywhere really, but a lot of times it's one of those two things. Sometimes you get a little rock in the front and it puts a little tiny pinhole in your condenser, but most of the time the failures are in the compressor, and they just, get old and they lock up. And that's where the problem begins when you're trying to fix this correctly, because these systems have to be absolutely free of moisture and any contamination, dirt or grit. So if you're replacing the compressor and if it's failed from locking up, then the whole system is contaminated. And with a contaminated system, everything has to be clean and dry. And in order to do that, you can flush the system, but it really doesn't get everything. If you have a compressor failure, the best thing to do is obviously replace the compressor, replace the receiver dryer, replace the expansion valve or orifice tube. And I highly recommend you replace the condenser. It's not that big of a deal to do. In a perfect world, you would also replace the evaporator, but most of the time on vehicles, you have to pull the dash to get to it. And usually you can get those flushed out pretty good because they are small enough. The condensers are another story. Plus, a lot of times these condensers are all chewed up from 100, 200,000 miles of driving through road debris and insects. So it's just a good idea to replace that anyway. And then you have to flush out all the lines and make sure you get the debris and all the crap that the compressor put through the lines clean as well. And to do that, like I said, everything has to be very, very clean, and that's where a lot of guys get into trouble. They don't spend the time and get everything spotless. And then once you get that all done, you have to evacuate it down, put it under a vacuum, and what that does is it eliminates any moisture in the system, and then you recharge it. And I will say there is only 3 things that should be put in an AC system. 1 is the refrigerant. 2 is obviously the compressor oil that lubricates the system. And 3 is UV leak detection dye, which that's acceptable as well. Under no circumstances would I ever recommend the AC stop leak that comes in these cans. That stuff is absolute complete shit, and it does not belong anywhere near an AC system. So I guess my bottom line takeaway from this would be, if you have to replace any O-rings or hoses on your system, just make sure, or any components for that matter, just make sure everything is clean. Don't introduce any dirt or debris into the system. Make sure it stays spotless. Only put refrigerant, oil, and possibly UV detection dye in the system, nothing else. And happy AC pressures are anywhere between 40 up to about 45 PSI on the low side, and no more than 225 on the high side. Try and keep those under 200 or roughly around 200, and you should be good. Okay, one more thing I probably should address here, and that's for the guys that are probably watching the video that are charging their vehicle with refrigerant with one of the parts store, do-it-yourself cans, and because all you're going to be seeing is low side pressure on those gauges. And let's say you start adding some refrigerant and you're up to 40, 45 PSI, and it's just starting to kind of cool, and so you're like, okay, add more. Your pressure starts to come up 55, 60, 65, 70 PSI. That can mean a couple different things. It can mean, one, you've got too much refrigerant, you've overcharged it, but most likely what it means is you have a problem with your AC system. Say this is running and your pressure on the low side is reading 68 PSI like it is here. A lot of times that doesn't mean you're necessarily overcharged. A lot of times what that means is you have a failing compressor. The compressor just isn't pumping refrigerant like it should be, and it's worn out. And if you were able to connect the high side, you would probably see that the high side pressure is actually very, very low. These two pressures are very close to another, in which case that means you have a compressor failure and you need to have basically a whole system replacement. So if your pressure is high on the low side and you really haven't added much refrigerant and it's not cooling, or it's just basically blowing slightly cool air, unfortunately for you, you probably have a lot bigger problems than just a refrigerant leak. Okay, so let's say you've got everything all charged up and you go to remove your low pressure side and you hear that sound. You got a leak coming from the Schrader valve. Well, there's pretty much only two ways to fix this problem. First, go ahead and I clip that back on and I'll show you how I fix it. And the other way is pretty much to evacuate the whole system back out and replace the Schrader valve. Go ahead and vacuum it back down and recharge it. Or you can do it this way if you have some special tools. This is not the only kit they make. There's other kits that they make for this exact same thing. This just happens to be the kit that I have and I use. Pretty much for anything R-12 and R-134 related. And for this particular job, it is going to be a small Schrader valve. So I'm going to go ahead and use my number 1 adapter, adapter. Okay, so got my quick connect screwed into shutoff valve here. It's finger tight. Gonna go ahead and turn the valve closed. I'm gonna try and do this one-handed to show you guys. Take my low pressure off. Gonna clip that on there. Make sure the valve is shut. Taking the Schrader core tool, gonna thread it onto the junction block there. Make sure it's good and finger tight. Gonna release the pressure on it right here. It's open. Now this is under just a little bit of pressure. You want to push that down until it connects and contacts with the Schrader core. And then while pushing down, thread that out. And you can kind of feel when it comes out all the way because it makes a little bit of a clicking sound where the threads are disengaged. Right there. And the pressure and the coupling device should allow it to come out with the tool. Just extend it all the way out. The shutoff valve is definitely still shut. I'm gonna unthread the top part of the tool. Focus, and there's your Schrader core. Focus. Okay, so got a new Schrader core on our tool. Just going to gently drop that in there. Slide that down. Thread that back on. Make sure she's good and tight, sealed. Open this up. No leaks. Slide this back down. It's got a little bit of resistance on it from the pressure of the system. And that pressure can be anywhere from 80 to 100 PSI static on average. I say on average. Sometimes more, sometimes less. And I like to have it good and snug. And just to show you how confident I am, I'm just gonna pop this off all at once. There you go. Now, this will no longer leak, hopefully for another 20 years. Give it the old spit test. A little bit of soapy water or soap actually works a little better for that, but you get the general idea. Put the dust cap back on. Good to go. Well, I guess that's some of the basics. You got one AC leak fix. You got what to look out for pressures, some of the failures to look out for when adding refrigerant, what to look out for with the pressures, what they mean. So hopefully this does something for somebody that's looking for answers. Well guys, I hope that helped out anyone that had any questions on how to add refrigerant to their car or truck. I know that's just barely scratched the surface. There's a lot more stuff that you really should know if you're getting into any type of major AC repairs, but for those just wanting to add some refrigerant to the car and didn't really know what to do, I hope it helped out. I'm going to be doing some more videos in the future about diagnostics, checking for draws on vehicles, and some more basic electrical stuff when it comes to fixing most modern cars that a lot of people might get into. So stay tuned for those. Those will be coming soon. Until next time, we'll see you guys later. Have a good one.